Good afternoon, dear participants of the conference. Today, the authors from Kharkiv National University of Radioelectronics present the paper called Comparative Analysis of JMeter and Postman for API-based performance testing. API performance testing using Postman and JMeter tools has become increasingly important due to the rise of microservices, along with the need to support growing user bases and data volumes. One of the challenges in performance API testing is increasing test speed and efficiency, as well as reducing overall time needed for testing. Distributed nature of microservice application with APIs leads to resources limitations, where costs are correlated with resource allocation and overall testing time. Postman and JMeter are popular tools for API performance testing. However, they have architectural differences and offer different options for load generation, work collaboration, and reporting. These differences raise questions about efficient selection of a suitable test tool that can be aligned with the project's requirements. This will help make informed decisions during creation of a successful testing strategy. The aim of this study is to compare Postman and JMeter as tools for performance API testing. By evaluating their performance metrics such as average response time, minimum maximum values, and error rate, this research aims to determine which tool is more effective in different testing scenarios. In order to conduct performance testing and compare results between both test tools, it is necessary to solve a number of tasks as shown on this slide. So, the following 5 public services with public APIs were selected for performance testing, offering mock and real data for testing as shown on the slide. Tests were organized in form of Postman collections and used different types of thread group and loop controller elements in JMeter. In order to get objective comparison results, all requests were identical between the tools and were directed to the same public APIs. On this slide, you can see 8 test scenarios used in performance testing. Each scenario involved sequential execution of HTTP requests plus delay request after each of them. In both test tools, performance testing was conducted under identical conditions: number of virtual users, sync time, and test duration, and different type of loads, ramp up, spike, peak, and fixed type, were applied as shown on this slide. After performing testing, difference in performance metric values, deltas, can be calculated to analyze which types of requests were slower in Postman or JMeter using Formula 1 on this slide. In case delta average is a positive value, then Postman had a longer average response time than JMeter was slower. Next step was to calculate the aggregated mean values of each performance metric for 8 test cases. For each API and HTTP method helps to provide a representative performance assessment. As a final step, mean aggregated values were calculated for average performance metric values for selected HTTP method across 5 APIs, as shown in Formula 3 on this slide. Results of aggregated mean performance test metrics from hundreds of requests show that Postman demonstrates better performance comparing to JMeter, as shown in table in this slide. However, negative delta values indicate that Postman was faster in low to moderate load conditions, as shown in figure 3 in this slide. On the other hand, JMeter illustrates higher performance under the conditions of high load and request intensity. Sharp increase in load to peak, followed by a gradual decrease with a short sync time, as shown in figure 4. To conclude, using Postman as a tool for performance testing in low to moderate load condition would provide a step forward for small and medium-sized organizations and firms in their efforts to achieve a good software quality level. Additionally, using JMeter could be beneficial for complex cloud services and distributed systems with high load and request intensity. Obtained results could have a profound impact on selecting appropriate performance testing tools. Considering factors such as complexity of returned responses and planned load parameters, like virtual users, sync time, test duration, it is possible to ensure a reduction of testing time and a risk of underestimation of the system in high load conditions. So, thank you for your attention.